Now that a strand of mRNA is synthesized, it's time for the mRNA to be translated into a protein. Similar to transcription, there are also 3 general steps in translation. To begin, it's important to assemble the alpha and beta of 40S small subunit and 60S large subunit of the ribosome. So here's the 40S subunit, and here's the 60S subunit. And then we'll also have our mRNA we synthesized with the 5' cap and the poly A tail. And now we have the initiation complex. Well, lastly, we'll have 3 initiation factors to come in to kickstart initiation. Once this is assembled around the mRNA will begin to be read at the start codon, AUG. And we start reading after the 5' tail. So the start codon, most notably, is AUG. So when each preceding codon is exposed, a tRNA with the corresponding anticodon and amino acid will bind to the codon. So here is our tRNA with its anticodon as well as the accompanying amino acid. So as you can see, tRNA will enter through the A site within the ribosome, and then the ribosome itself will shift over to the P site. So in this example, I'm shifting over mRNA, but realistically the ribosome will be the one moving over. So now we all move over one spot. So AUG is now at the P site, as well as the tRNA and the movies over and the amino acid. So next, let's say we have G, C, and C. And here's its tRNA with its anticodon and the amino acid. So at the P site is where the peptide bond begins to take form between the 2 amino acids within the P and A site, and that peptide bond will be presented as this little segment. So once the third tRNA comes in with its respective amino acid, another peptide bond will form between the P and A site. So everything will shift over again. And let's say the third codon, we have A, C, and A. Here's the tRNA with the anticodon and the amino acid. So here another peptide bond would form. But the tRNA on the E site no longer has anything holding it in place now that the peptide chain has formed. So the tRNA at this site would just drift away. So as the mRNA is being read, the codon will correspond to one of the 20 amino acids that tRNA will then transfer. Enough amino acids will be transported in by tRNA that a peptide bond will form in order to synthesize a protein or polypeptide chain. So this segment right here will look a little bit like this. And this process will continue and is known as the elongation stage. Additionally, it's important to note that the last letter of a codon tends to be degenerate and is known to wobble. This means that the third position does not matter per se as much as the first 2 positions. This allows certain mismatches to be tolerated without having severe repercussions on the protein. So ultimately, the mRNA will approach a stop codon, which will terminate translation. The ribosomal subunits will then separate due to those termination factors, and the nascent protein, which might look something like this, that we just synthesized, will be released. Some post-translation splicing may be done in order to polish up the protein and ensure correct folding.